This is Smart Academy. We are giving CSIR net just get classical mechanics classes. We started with classical mechanics. Today I am explaining Lagrangian formulation. Today I am going to explain Lagrangian formulation. If you have notebook, please note this how it is going. See, this is Lagrangian formulation. See, let there be a system of particles of a generalized coordinates to specify the system. See, take a system of particles f generalized coordinates needed to specify the system. This is we assumed one system. According to transformation equations, the position vector of ith particle, that is Ri equal to Ri in terms of generalized coordinates and time. So Ri in the function of q1, q2, dash qf comma t. See, next, consider any particle of the system of mass mi. Any particle you take from the system, any particle that has mass mi, the force on the ith particle, that is Fi. See, we consider a particle of mass mi, the force on ith particle, that is Fi. So according to D'Alembert's force, the sigma Fi dot pi dot delta I, that is equal to 0. So this is the D'Alembert's equation. See, here Fi is force on ith particle. This pi means momentum. Mi Ri double dot delta Ri equal to 0. Here just we multiply this one, Fi dot delta Ri, that is equal to sigma mi Ri dot delta Ri. Here what is delta Ri? This is virtual displacement in terms of generalized coordinates. Just substitute in this equation. So wherever delta Ri is there, sigma k dou Ri by dou qk delta qk, here also we substitute. This is equation first. So I am giving only equation first here. See, here we have some doubts. Not doubts, we have to substitute some. See, here Ri double dot, this is the acceleration in Cartesian coordinates of particle. So go to here, but d by dt differentiation with time, d by dt Ri dot dou Ri by dou qk, that is equal to, it will come. So finally Ri dot dou Ri by dou qk equal to d by dt of this equation, we got this one. We substitute here. In this point we substituted here, then we substituted here, and after substituting, so what do we have? Sigma k mi d by dt Ri dot dou Ri by dou qk. So whatever this one, so for this we did this one. This is a position vector in terms of generalized coordinates. Differentiate with time. This one Ri dot k taken, sigma k taken 1 to dou Ri by dou qk dot plus dou Ri by dou t. Then finally one more time differentiate with qk dot. So dou Ri by dou qk dot dou Ri by dou qk. Then do partial derivative. So dou Ri by dou Ri dot by dou qk dou square R1 by dou qk dou q1 dot, like this. So finally from these two equations, d by dt of dou Ri by dou qk, that is equal to dou Ri by dou Ri dot by dou qk. So this is a simplification. Substitute here this one. So finally after substituting, what we will get? See here, sigma k mi d by dt Ri dot dou Ri by dou qk minus Ri dot d by dt dou Ri by dou qk delta qk, that is equal to sigma k Fi dou Ri by dou qk delta qk. So just to substitute This in this one we will get like this: sigma k mi d by dt of dou by dou qk of ri dot square minus ri dot to ri dot by dou qk delta qk, that is equal to sigma k fi dou ri by dou qk delta qk. So this is after substituting this one we got this equation. So after this one, sigma k d by dt dou by dou qk dot dou ri by dou qk dot sigma I mi of ri dot square. See here we multiplied mi inside, we send mi inside the bracket. So this one minus dou by dou qk of mi ri dot square, that is delta qk sigma I sigma k fi dou ri by dou qk delta qk. See here we substitute this one, we got this one, so that is equal to, here we have C of mi ri dot square, that is equal to total kinetic energy of the system, total kinetic energy of kinetic energy of the system. So substitute T, so we will get sigma k d by dt dou t by dou qk dot minus dou t by dou qk delta qk equal to sigma I sigma k fi dou ri by dou qk delta qk. So what is this? Sigma k d by dt of dou t by dou qk dot minus dou t by dou qk delta qk equal to sigma I sigma k fi dou ri by dou qk delta qk. So sigma I fi dou ri by dou qk delta qk, we can write qk. This is generalized force. So we substitute, we substitute there, finally we will get this equation: sigma k d by dt dou t by dou qk dot minus dou t by dou qk minus qk delta qk equal to 0. If qk coefficients, delta qk coefficient goes to 0, then sigma k, so coefficient 0 means sigma won't come here, d by dt dou t by dou qk dot minus dou t by dou qk minus qk equal to 0. So this d by dt of dou t by dou qk minus dou t by dou qk, that is equal to qk. This is Lagrangian equation. This is Lagrangian equation. What is this? D by dt of dou t by dou qk dot minus dou t by dou qk, that is equal to qk. This is Lagrangian formulation. This is Lagrangian equation in terms of total energy. So here this is d by dt have dou t by dou qk dot dou t minus dou qk equal to qk. This is the general form of Lagrangian equation. This is important for CSIR, net, whatever it is. All physics exams, they may ask the direct question also. What is the formula of Lagrangian equation? So there are f such equations with corresponding f generalized coordinates. The above equation has derived form of in this form there is no constraints. The system we are not considered initially, we not consider the constraints not involved in the system. If this system, if we consider holonomic constraints also, the equations of constraints may be used to minimize the degrees of freedom. So if we consider also, there is no problem. This is a Lagrangian equation without considering the constraints. That is d by dt of dou t by dou qk dot minus dou t by dou qk that is equal to qk. So this is a Lagrangian equation. Here we not consider constraints. We not consider here constraints here. This is a Lagrangian